Now, I don't think you can use the formula, but I think you can. So I just want to double check that the formula still works even if it's a rectangle and not a square. So can you look up, please? So we imagine that here is our rectangle, and this is L, and this is W. They're not the same. You got that? So the formula for the torque is still the diameter multiplied by the force, and here the diameter is W, true, and the force is BILN. But you notice you still have a W and you still have an L in there, which still makes an A. So in fact, yeah, you can still use the formula. But like I said, I wasn't 100% sure from my memory if you could, but it turns out a quick check and you can. So it's still area, like you were saying. So here, what's the I, please? 2.25. 2.25. The B? 0.2. The A, well, what's the two sides?
0.01. Oh, not enough that.
Yeah.
15.4 times 10 to the minus 2.
Yeah.
9.6 times 10 to the minus 2.
And then the N?
Get that.
Oh, it just wraps around once?
No, the total length of the wire was 45.
Ah, very interesting. So you have to work out the N. So how long is the wire that goes around it?
45.5 meters.
45.5 meters. So to work out the number of loops, you'll have to divide it by the total perimeter, which would be this plus this plus this plus this, which would be 2 of these and 2 of these. So if I just add them together, they were a little bit sneaky, didn't make it too easy for you. 15.4 times 10 to the minus 2 times 2 plus 9.6 times 10 to the minus 2 times 2. So that's a half a meter. So that goes around 91 times.
So you have to do a calculation?
Yep. Calculate what?
The number of loops.
The total length?
Total length?
Divided by the 4 sides added together. This 0.5, the 0.5 was L plus W plus L plus W. So it's the total length divided by how much one loop would be.
So total length divided by total size.
Yeah, which is called the perimeter, if you're wondering what the word is for that. So 2.25 times 0.2 times 16.4 times 10 to the minus 2 times 9.6 times 10 to the power of minus 2 times 91. .605 newtons. Now, I think the only difference in the B part is the angle is now 60. So that is 0.605 cos, isn't it? Or is it sine? Well, I don't remember. We just had the formula a second ago. It's the second formula.
No, you say you should find the magnetic flux linkage.
Oh, sorry, I misread it down. What do they want?
Magnetic flux.
Ah, okay, okay. So what they have, you got your north, you got your south, and the field goes like follows. And then the coil, when the normal of the plane makes an angle of 60 to the flux direction. To the flux direction? Okay, so we have an angle here. And I think what they're trying to say is that this here is a 60 degrees. Okay. So you remember your formula, the total flux linkage, N flux which is NBA. Although this one here is at an angle, so we have to stick in our cos 60. Now the n we know, what's the n? 91. The b we know, what's the b? 0.2. The a we can work out, it was the two lengths multiplied together, and then we have a cos 60. So if I just grab my two lengths, which I don't even remember what they were. What were the two lengths?
15.4 times 10 to the minus 3.
Yeah.
And 9.6 times 10 to the minus 2.
So here the area is 0.014784 times cos 60 times 91 times 0.2. So here you get a total flux linkage of 1.35 Webers. So it was nice to do these two section A questions right after doing the lecture on this, so you can see what it's like in the exam. So if you practice, it's not too difficult, not at all. Okay.